warm welcome to everybody. And thanks Open Source India for arranging such a beautiful community, I would say, for like-minded people to interact, learn, and apply in our day-to-day lives. All right, welcome everyone once again. So today it's going to be a very interesting topic surrounding the smart factory ecosystem. It's called Building Smart Factory Community. So a quick introduction about me in terms of why I'm doing this today, right? So I've been working in the space of digital transformation and smart factory and smart manufacturing for quite some time now. And I wanted to share with this community in terms of what it means to build a successful enterprise level digital transformation and how open source plays a pivotal role. So that's the purpose for me to come here and then talk to you guys. And it's been a pleasure for me to actually share what I know with the bigger community. All right, so today we're going to be talking pretty much into the smart factory ecosystem. What is the current state and why do we need to build a community that is having its roots and fundamentals on open source? Right. So today we will also look at real-time use cases or real-time scenarios that have occurred in the past and how this emphasizes and re-emphasizes the need to have a community. Right. So this is a chart from the PAC Radar, a renowned European-based organization that does market study. So in terms of looking at the applicability for IoT, which has been talked about for over a decade now, the major emphasis or the selling area is at the digital factory or the smart factory domain, where we have a lot of money that is readily available in terms of revenue opportunities and in terms of application opportunities. So we're going to be focusing today on this topic of digital factory, while everything else is also synonymous in terms of, say, the data fabric and the IoT components that are involved into it. So we're going to be talking mainly on the digital factory side. All right, let's start with a zoom out picture of our world in terms of the entire supply chain. So this is the traditional supply chain, and I would call it the curious case of products. So it gives us a wagon wheel of how we build our products, starting from planning, and then we plan for a particular product, and then we understand that it needs to be sourced from various suppliers because we cannot manufacture each subcomponent of the product. So we work with multiple suppliers. We have our own development team that does the R&D, and then comes the production phase where we integrate various components from various suppliers, and then we build the value-added product in our factories. So this is the green area that we're going to zoom in today. But overall, zooming out, this is the entire supply chain. And then you look at how do you dispatch your orders, how do you store your orders, how do you distribute it to the end customers through your outbound supply chain. And then you also have the closed loop where you have the relationship management. You understand the feedback from the customers who use your product, and then that goes back as your input to your R&D, and then you start building or start refreshing your product, right? So this is pretty much true for any product that we build. Take smartphones for an example. So year on year you have refresh. You understand how each year the phone becomes a little more refined. So a lot of it is due to the cyclical phenomenon. So instead of looking at it as a linear product, I would like to consider this as a cyclical chain where you have each module giving in feedback into each of these models. So this is a connected sphere that I would call it, a multi-dimensional connected sphere that feeds data into each of these modules, and we build better products every day. Right, so we're going to focus on this green box today in terms of production, which happens in Smart Factory, and we're going to look at the ecosystem of what is happening today and why there is a need to build a community around it. All right, let's look at what is in a shop floor, a typical shop floor. A typical shop floor is a manufacturing entity that has machines, it has production layers, it has production lines, and then it also has the automation that is built in to run those machines. So the level 0, 1, and 2 of the ISA 95 standard. So I'll come back to the ISA 95 standard a little later, but overall, this is the ecosystem. The blue box represents the ecosystem or the machines at the shop floor. Next is the level 3, where we are trying to accumulate data and then send the data to create intelligence out of that data, right? So this is where you have the level 3 that usually comprises, or we call it edge. You can call it different names, manufacturing execution systems, IoT, and so on. But this is the hardware layer that basically has two components. One is the constrained devices, and the other is the powerful edge gateways. By constrained devices, I mean you have say sensor modules, sensor modes, LoRaWAN modules that stick onto any of your machines, maybe the legacy systems, and then pull in information and then communicate it to the nearest gateway. So these are resource constrained IoT devices that probably run on RTOS, and that also has a communication built in. So these are one types of devices that are available. The next is the edge gateway, which is a powerful ecosystem for edge computing, which runs OS. Probably it can also run container orchestration. It can run Kubernetes systems and applications and so on. But primarily the objective is to connect with the constrained devices and also the machines below to acquire data from them and then transport it to the higher layer, right? So this is the edge ecosystem. And then the next is where the enterprise comes in, where you have the business layer, the production layer, the entire supply chain module, supply chain management that we talked about in the previous slide. So this is what happens at the plant. Then moving to the cloud. So this is where the cloud comes in, where you have the entire data pipeline, where you ingest data, you connect with multiple edge components, assuming you have, say, a lot of plants, a lot of production lines, you've taken data from multiple edge gateways, bring it into your cloud, you store your data, you extract, you transform, and you load. So you do all this operations on at the cloud level. This is the cloud data pipeline that we talk about. And then you have the microservices that also run in terms of measuring application performance. You also have various applications that are built on top of data. So once you have the data, we create applications here at the cloud level. Finally, and the most important thing is the user. So at the end of the day, we are building users, and industry 4 still has users at the center of the ecosystem, because the users determine the success or failure of any of the product that you build. Because if you build a product that nobody uses or nobody wants to use, it does not make sense at the end of the day, right? So you have the users that form the fulcrum of the industry 4 ecosystem, who also consume data, but then each of them is a different persona by itself, and then they need data in different formats, or they want to look at data in a different dimensionality as such. So this is where the intelligence that we build in. So the reason for bringing in this diagram is to kind of show you the complexity that is involved in any of your smart factory ecosystem, right? So there are so many components, and each of these components, if you double click, there are thousands of vendors that operate across. But then this is a typical example or typical scenario in any of the manufacturing use case, where you the data finds it very difficult to start from the actual machine and then to reach to the end user, where he can actually take real-time decisions based on what is happening with his data, right? I mean, what is happening with his asset. So this is a very complicated ecosystem, and this pushes for a definite case for having a common backbone, or a common understanding, or a common language that everybody understands and operates, right? So this is what we call as a digital thread, and data interoperability becomes major here, or very much important, because that defines whether two systems talk to each other, right? If these two systems do not talk to each other, then the entire ecosystem fails, right? So this is an important lever for bringing in this the importance of open source and the importance of community in this space. So by the way, on the left is what is called as the ISA 95 architecture. So I'll talk about why do we need a reference architecture, what role does a community play in defining the architecture, and why do we need a common consortium so that everybody speaks the same language. Right, so this is the entire summary of how a smart factory ecosystem works. Now let's jump back into a live story that I would want to tell today, in terms of how all this will help us build a better product for the end user. Okay, so this is a live case study from a company called Hire. So Hire Manufacturing, as you guys know, they manufacture consumer products, they manufacture electrical goods, but then they transformed consumer goods into lifestyle products. So by what I mean by lifestyle products is that they manufacture products that are specific and customizable to the end user. So instead of mass manufacturing, which is a tenet of Industry 3, so Industry 4, what we're trying to do is to do mass customization. So what it basically means, you have the user at the center. The user defines what he wants, and then there are various other components that we talked about, right? The suppliers, the manufacturing company, the supply chain, all of them adopt to or adapt to what the user needs. So here a company on the right side, what you see is they built this interaction platform called Cosmo Plat, where the user could come in and then say, okay, my living room is so-and-so dimension. And then the system would recommend, okay, you would need such a air cooling system, you would need such a refrigeration system, you would need such a microwave system, and the user would have the ability to customize his product depending on his taste and his use cases, right? So instead of manufacturing a standard product that may not be relevant, so you cannot have a 3-ton AC for a very small room and so on, right? You build a product that is actually needed or used by the end user. So basis his input, the entire also built a platform where you can actually 3D print a specific component into your product, right? So this is where we combine, say, additive manufacturing or 3D manufacturing into the entire ecosystem, where you have a personalized product that is specifically manufactured with your name. So this is the power of say a common ecosystem where you have user at the core of the entire ecosystem, right? So this is one use case which transformed hire into a commodity manufacturing or a electrical appliance manufacturing company into a lifestyle manufacturing company, where they put the customer into the core by where he was able to exchange design information, he was able to tell what he wanted, and then this platform would communicate with the design service provider, the development team, the suppliers, the manufacturing company, and then they used to integrate this, and then this eliminated the entire middleman in the ecosystem, where the product could actually be shipped from the manufacturing unit directly to the customer, right? So this is the value that we see here in terms of having a common data layer into the platform. All right. Next is a very interesting story that I would want to talk about, which is Indian confectionery manufacturer. There's a real-time study that we were able to undertake where we wanted to see what was happening, right? So this confectionery manufacturer used to manufacture chocolates, and these chocolates were temperature sensitive, as you guys know. If you keep it outside of the refrigerator, they would melt, and nobody would buy, right? So it would become a negative brand value if you sell chocolates that are molten. So it was very imperative, more than the design of the products, that it has to be refrigerated at the end retail point. But they were not very sure of how the entire ecosystem would play about. So the current scenario was they had to tie in with a cooler manufacturer who would actually sell the coolers to this food and beverage company. But then this cooler manufacturer needed the compressor, which actually comes from the machine manufacturer. So this machine manufacturer used to manufacture compressor and then sell it to this cooler manufacturer guy, and then he used to forget what he sold. So there is no connection here. So this cooler manufacturer would assemble the compressor, the cabinet and electrical unit, the controller and so on, and then sell it to the food and beverage company. So this food and beverage company used to kind of package this, label it, brand it, and then send it out to the retailers. And then the retailers would actually have the refrigerating unit at the end point, and you never know what they store in the refrigerator, right? You can as well go and store, if you go and look at any store today, you can as well store non-brand products into that. You can actually use it for your personal purpose. Most of the storekeepers, I mean, looking at a real-time case study here, we found out that most of the shopkeepers, you would actually have 3 to 4 refrigeration units, which they would actually use it for their personal use inside their homes, because most of the kirana stores have a structure that they are an outlet to their houses. So every in front of their house they have the store, and then at the back side they have their houses, and they used to actually use them for their personal use, or they would, even worse, they used to store the competitor product in the same refrigerator, right? So, and then when you look at the consumer who is at the end, who is trying to buy product, so he's actually confused. So if you look at a competitor B's product into competitor A's storage unit, the branding goes for a toss. All the money that is spent on advertising goes for a toss. And even otherwise, if the refrigerator does not work at the end unit, right, so the product gets damaged, and overall the sales get disturbed. So the essence of this is, even if you have a winning product, you design a great tasting chocolate, at the end of the day, if you do not have this figured out, right, so you are at loss, you do not know what to do. And this is a very real life case scenario that we had solved for them in terms of creating a common language or a common data fabric behind. And this was actually achieved using open source as the backbone. So we'll see that in the next coming slides. But overall, the message that I would want to convey is, even if you have a winning product, you need to look at the entire ecosystem. And the ecosystem today, for good or bad, is completely dispersed. But then in order to talk to the dispersed ecosystem, you need to have an open mindset and an open framework with which you can operate. All right. Moving on, looking at the cross company value-added network, right? So combining these two use cases, or these two stories that I shared, where we talked about Hire as a manufacturing unit, where I want to quote, since that data, the case study is in public, and the other one is the confectionery manufacturer, which I was part of in terms of the case study. So I wanted to talk about this important slide where we are actually integrating with multiple stakeholders within the value-added ecosystem, right? So you do not, the manufacturing company definitely is at the core, but then there are various factors, that various stakeholders that play a very critical role in success of this particular product that comes out of the manufacturing company. So basically, each of these boxes that you see is a product development lifecycle in its own. So for example, a machine supplier will have his own design unit, the planning, the building unit, the service unit, everything built in. So it's an independent system on its own. And then you have suppliers, which is also an independent unit. And you also have a manufacturing service provider, which is needed. So what we need to focus here are two things. One is the system integrator, and other is the marketplace. So for the system integrator, he needs to talk a common language that all the suppliers would know and all the service providers would know, so that he can actually integrate everything and create an ecosystem where everything talk to each other. All the machines can convey and talk to each other. And the other part is the marketplace, where, for example, if you have a request to manufacture a 3D part, you don't have to go today and search for which company manufactures it for me. So you actually have a marketplace that understands your need and then transposes that into a broadcasted message that anybody in the field, like you group it, it's more of a marketplace or e-commerce place for manufacturing that will be built on the open source terminology, because this marketplace understands needs, because the framework is built on open source, and he would be able to search and give you the best value product that the manufacturing company needs. So the emphasis is on the common framework that is needed. And we would go in the next slide to talk about how a common framework or a community gets created. Right. So basically, it starts with a consortium which defines a format that says, okay, so if two people do not know, it's basically recreation of how languages evolved in the evolution of humans. So we all agreed that English or any other language, we agreed that these are the terminologies. A rat means a rat, a bat means a bat. So we all defined what it means. So we had a consortium that defines or publishes a reference architecture. And then you have a community, right? So this is where we want to stress today on. So a community basically adopts it, owns it, and then actually makes it even more better. So let's take a specific example here where we look at OPC as a foundation or a consortium that defines how a machine would talk to another machine, or how a machine would send data to a control layer, right? So this is the OPC foundation. And then you have OPC UA as a reference framework that gets defined out of it. This is like the dictionary of English. So this is English as a language. This is a dictionary that gets created. And then this is where the users or the community uses this as a reference architecture, and then they create books out of it, right? So this IEC 62541, which is a standard for robotic communication or machine communication, is actually a book that the community actually produces. So we as a community here are responsible for creating this book that this machine utilizes, so that we understand what this machine talks. So this is the entire ecosystem. So once you have this community in place, so any machine that goes by this book should be able to talk to this manufacturer, and this ecosystem gets well integrated. So this is the crux of what I wanted to convey today in terms of how a basic rule set is needed, and then how a community plays an important role in adopting that particular rule set, builds on top of it, gives feedback, develops it, and then make sure everybody follows that particular aspect. Right now, if you have English as a language, you can go to any part of the world and then probably converse with anybody and talk to anybody, right? So that's the kind of analogy that I wanted to drive in here. So this is the double click into the community. So next part, what I want to talk through is a very interesting website that I would want you guys to go through if you are interested in Industry 4. So this is a 2030 vision of how Industry 4 would evolve. So they're not calling it Industry 5, but it is Industry 4 with autonomous thinking, right? So we talked about mass customization instead of mass production. We talked about end-to-end supply chain integration. And this is where this becomes very interesting. So the reference is given here. You guys can search on Industry 40 .isometric. And this is a very interactive website that gives you a double click and triple click into each of this. So if you click on autonomy, it takes you into what technology is there, what is the infrastructure that is needed, and what security is needed, and so on. So, but basic fundamental principle on what this is built on is open source, right? So we want to define a system that is, if you look at the pillars here, all of them are actually the pillars of why we developed open source at the first place, right? So you need to have autonomy in the sense that you need to know, you need to decide what products you want to work on, and the product should automatically fill in, right? So the biggest problem today in any of the industries is this concept called vendor lock-in, right? So when you choose a particular vendor, so this is not against any of the vendors, but this is more towards propagating how we want to build on open source. So vendor lock-in is a bigger problem because you go to a particular vendor to solve your issue, and then that issue gets solved. But then if you look at a different problem, then you'll have to go to the same vendor again, and that's where they make a large volume of money, where say you have to buy this adapter, you have to buy this piece of application, and then everything works as expected, right? So you do not have the freedom or the kind of independence of choice where you are able to work with a diaspora or a dispersed ecosystem of vendors. So autonomy, interoperability, and sustainability are all basic tenets of open source, and that's the very heartening part, where all of them go together to collectively define the vision for Industry 4 as it would be in 2030. All right, moving on into the same double click of the previous slide, where we want to look at a complex three-dimensional view of the same. So I talked about the entire ISA 95 model, where we started with the machine. We went into how will you connect a sensor to the machine, take the data. If you have a PLC, send the data to a edge component, send it to a cloud, do data analytics on top, derive your applications, and then finally go to the end user, right? So this is the axis that is shown here. We can call it probably x-axis, where you have the product, the device, the control, and then it goes into the enterprise and the connected world. This is on this axis. And then on the z-axis or the y-axis, if you may call this. So this is basically your dev environment or a production environment, where you have your own set of product lifecycle, where you mature your product and then deliver your product. Vertically is where you have various stakeholders, starting with the asset, how do you integrate, how do you communicate with the device, how do you have functional requirements, and then business. So this is the similar view or a three-dimensional view of how the entire ecosystem comes in. The reason for showing this is at the intersection of this cube is the open source framework, right? So if you do not be open, or if this layer of any of these layers are not talking to each other, the entire ecosystem fails and you do not have data going across any of this. And since we talked about the importance of data, and this becomes more than important to have a collective framework or collective ensemble on this. Okay, let's go deeper into how do we develop communities, right? So all of us are enthusiastic or interested probably in developing open source. So the reason why people choose open source or choose community is they want to learn new things, they want to contribute back to the community when they learned. So that is fundamental to it. And then you also want to work with like-minded people who share your own vision, or they share a common vision for the development of humanity, right? So this is where a community-based development takes precedence. And there are two types of community, right? So you become associated with individual structures of projects, individual projects that you see on GitHub that you want to be part of. You write your code, you merge with that, and then you start contributing towards that. And then second part is you work with a bigger consortium of sorts where you have major players, you have a global community kind of a vision, and then you build towards the vision of the community. So today we are going to majorly focus on the second part, where we are going to look at community-based development and more so on how we actually make money, right? At the end of the day, the product needs to be successful. The product needs to solve the problem of the end user. And finally, it also needs to make financial sense. So at the heart of all this is where we want to play safe. The intersection of feasibility, usability, and adoptability is where we want to play today, and then see how we can still leverage open source, still have the same open source frameworks, but still make money or make financial sense for working or putting our time into it. Okay, so this slide is again, or this data is again from this company called PackRadar. They are a very leading European Union firm that does market research. So this chart basically compares or plots the various ecosystems that are available today, which are built on openness or open digital platform, as they are called, because they are all built on open source technology. So there are different layers here. You have the market strength on the x-axis and the competence in the y-axis. The competence is defined by the number of projects that they own or the number of projects that they run, and then also the number of lines of code that the company or open sources or contributes back to the overall community, right? So, so if you look at, there are multiple companies which we do not want to delve into, but then the message that I want to convey is most of them are kind of together or kind of built on a foundation or a consortium that has a common purpose. So this is where the strength of a community comes to the foray, right? So, so the basic concept of a community is that we are all, as an individual, we are weaker than the sum of all of us. So when everybody joins hands towards a common purpose or a common vision, we build better things and bigger things and faster things. Right, so let's double click on one such community or one such ecosystem of Eclipse. So in the previous slide, we talked about the leaders here. So most of the leaders are part of this Eclipse Foundation, and Eclipse Foundation has a very structured way of looking at the smart factory as an entire commodity, right? So you have the entire ISA 95 model top down here, right? So this is the data aggregation. You send the data, you process the data, you collect the data, you store the data, and then you apply the data into application. This is looking at from top to the bottom. But then for each of these stack, you have open source alternates for any of these, say, vendor or enterprise applications that you might find. And all of them are enterprise grade, and all of them have active code, all of them are actively maintained, and you could directly leverage the open source licenses and build on top of that and communicate back, or build your application on top of that. Right. So we talked about, let me summarize until now. So we talked about the very complex ecosystem at the smart factory. So this is only at the smart factory level, but if you zoom out into the entire supply chain, it becomes all the more complicated. But even at the production center, you have multitudes of vendors, multitudes of systems, and all of them would need to share a common channel, and the common channel is the open framework that we talked about. And the reason for having an open framework is to make sure there are no vendor lock-ins, there are no proprietary software where we need to work with a lot of players which are not open, and you will not be able to achieve your end goal, right? So talking about the advantages of such a community which is built on open source, you actually save costs because you cannot keep developing software that you don't have to reinvent the cycle, right? You know what is already existing, what is already open, you can actually leverage them directly, and then you can build your application and the value addition on top. That is the number one number one driver that actually helps many people to decide on this path. Next is the interoperability piece, where you know there are systems that are open. You can look at the code, you know how the APIs are written, you know how the data modeling is done, so that you can actually connect multiple components together and make sure your application is successful. the independence, the customability, and the innovation part is going in hand, where you can actually have the freedom to choose the components that you want to use, the system players, system integrators that you want to use, the vendors that you want to use in your ecosystem, and then build a product, right? So this is where the power of open source comes, because everything is open, and you can actually choose what you want, what you do not want, and you can actually customize on top of that in terms of your tailoring to your fixed use case, right? So let's take an example here of building a predictive maintenance as an application for any of the assets, right? So predictive maintenance is one of the very top applications or top use cases in the manufacturing scenario. So this talks about analyzing a particular asset and then predicting when it will fail, or looking at a real-time health statistics of when it actually needs maintenance. So this can be made possible by using multiple open source stacks that we saw in the previous slide, starting with how do you connect sensors, how do you access data, how do you send data, the telemetry of the data, how do you store data, how do you run open algorithms, how do you measure success, measure failure, how do you run machine learning, and then finally have the inference driving back the user behavior. So all of this is definitely possible through what we call the open framework, and then this definitely drives value to our community. All right, so this brings me to the most important slide for today, which I wanted to talk about, because at the end of the day, it needs to have financial sense, right? So it needs to be profitable. It needs to be useful for the community as such. So there are two aspects why people contribute, right? So we, as passionate individuals, we want to build products that are in alignment with our vision. But at the end of the day, somebody needs to use it and then say it has to make financial sense for them. So vendors today have a very premium way of making money, or looking at how they can actually utilize this open source framework to make money. So but there is a small difference that I want to bring about, because all of us know open source is free, but then how do we make money on top, right? So these are two different topics, but then when they combine together in this slide, they make business value. So I would like to spend more time here. So there are three major aspects where you can actually add value and then create an ecosystem that actually makes money, right? So there are hardware, there is software, and there are services that connect hardware and software that create value-added applications. So in terms of hardware, there are open hardware that is running, that runs your open source software. For example, your FreeRTOS, your base firmware layer that has data acquisition modules that are built in, and both of them go hand in hand. So when these two combine, the hardware and the software, you have the magic of the services, where a company that adopts open source can still go ahead and provide value-added services to the smart manufacturing OEM by following the following, right? So they can look at architecture and blueprinting of their existing ecosystem. They can drive business model innovation, where they can say, okay, this is your current business ecosystem or business need, and this is where you can actually build value to the end user or your own manufacturing setup. You can also do user adoption and training, where you can actually train the end user in terms of the various stakeholders that we saw, starting with the C-suite officers, say CIO, CTOs, and so on, up to the end user, like a worker who is, in my opinion, a very important stakeholder who determines the success of such a product. So consulting, system integration, hosting infrastructure, and maintenance support, right? So these are very, very important pillars where you actually can make money using the same open source software, but then you add value to it. So there has always been a debate in the industry where open source products are not scalable, or they're not industry ready, they're not resilient. But then I would probably argue the contrary, saying open source is where people can actually find flaws, they can find bugs on each other, and you actually have a very active community that somebody else can actually help you out in fixing your problem, thereby making the entire product foolproof and evolving and strong. So maintenance and support is basically a very important aspect here, where you can actually do this as a service. So if you look at major vendors of open source operating systems, for example, Ubuntu, Red Hat, they actually have the the operating system or the product as free. It is distributed, but then they charge for the enterprise support, where they help you in the maintenance and the entire operations of that particular product. So there's a very good freemium model that comes through. But in this context of Industry 4 in Smart Factory, these services are very important, and these are definitely major players or major market holders in terms of defining where the money actually lies in terms of creating value to the end user, right? And end user in the sense the entire OEM. So this is the crux which I wanted to say, because you have a community, you build a community, but what next? How do you make sure the community is actually successful, and how do you sustain a business model around this? So a successful startup can actually pick up this any topic in this area, and then you utilize the strength of open source software and hardware and build services on top. And these services are premium, and they can be used for generating value. All right, so we have almost come to the last, where I would want to summarize. So basically, there's a very famous quote by Brett Cannon, so who is a great contributor to Python. So if you guys know, so he once said he came for the language, but he stayed for the community. So this is a very powerful quote that actually says the value that the community brings in terms of the whole community is actually greater than some of its parts. Right? So we are all powerful than the individual powers of ourselves when we come together as a community. And as a community, we bring in ideas, we bring in knowledge, we bring in lessons learned, we bring in real-time use cases, we bring technical knowledge, and all of this together aggregates to form the value that we see in the entire ecosystem. Right, so we have almost come to the end of the session. So I would want to have the last few minutes as a live interaction with the audience if there are questions, or we can actually, if there is time, we can also permit, or we can also go into another real-time use cases. But overall, I would like to thank everybody for your time in participating in this short call. But then the entire Open Source India as a conference is pretty powerful, where EFI as a team is bringing in a lot of people, starting from presenters to stakeholders to audience, to kind of come in with the single purpose of sharing knowledge, right? So thanks everybody again for your time, for being here. And I would also want to kind of show you two important industry events that is happening. So the Eclipse Conference 2021 is a virtual conference that's happening from October 25 to 28. So this is where you can look at the entire Eclipse Foundation's open source stack, which is under development. It's a great place to unlearn what are all the features that are coming out, what are the new products that are coming out, what new projects are coming out at the Eclipse conference. And you also have the Industry Fusion. So this is more of the Industry 4 initiative that is also based out of open source. You can get to meet a lot of players, vendors, communities, and see how you can actually improve your knowledge and contribute back. All right, so this is my LinkedIn credentials. If you want to get in touch with me, definitely feel free to do that. And yeah, thanks once again for your time, guys.